Hi, this is Mr. Delobet, and today we are going to look at a two of the graphs in linear motion. So I want to give some examples on how to also draw these graphs for different systems or different situations. Now, before we go into that, I want us to also understand, especially when we talk about constant velocity, means the acceleration is zero. That's what I mean. So acceleration is we say acceleration is constant. We say the velocity is constant. Sorry, it's constant. It means we are saying acceleration is zero. And if we say the displacement distance is constant, means that we are saying that the velocity is zero. That's what we're trying to say, because velocity is a change in displacement over time. Acceleration is a change of velocity over time. So if the velocity is constant, means that the change over time is zero. Means that if today I have my velocity is 2, the next minute is 2, the next minute is 2. If you take 2 minus 2 is 0. That's why the acceleration is 0. My distance is the same, means that it's constant, and means that we say velocity is a change in displacement. Means that we say 2 every minute I'm at 2, every minute I'm at the 2 position. It means that 2 minus 2 is giving me what? 0, which means that the velocity is 0. So that's what you need to understand. We say constant velocity will mean 0 acceleration. We say constant displacement will mean 0 velocity. Now let's look at this problem. To draw a distance time graph or a displacement time graph, velocity time graph, acceleration time graph for the body at rest. When you say body is at rest, it means that the body is not moving. So it means that what? It means the distance is constant. It means that the velocity, the displacement is constant. So we're going to have, if we look at those graphs, the first graph, we're going to have something like this. This one will be for displacement, right? This positive, negative. So we have something like this. So that's A. You have to put your units in that. Now, if you want to draw a velocity time graph, and because the distance is constant, so what happens to our velocity? I know you can already start guessing. Because the velocity is constant, the displacement is constant, means the acceleration is 0. Velocity is 0. So it'll be here. But this is 0, this is negative, this is positive. So we have 0 velocity. It'll be here. Now we'll have no acceleration. Means the acceleration graph will just have something like this. We have an empty graph, right? Oh, sorry. We have yeah. So I really have no acceleration, because if this man is 0, then definitely acceleration also be what? The acceleration will be our acceleration will be 0, because we say this man is constant and this man is constant, man will be 0 like this, right? Yes. So that is it. So if you want to do the displacement time graph, the distance time graph for this one will be like, okay, you just have something like this. So this is, so we'll have the same like this. Speed time graph we have, if you want to draw the speed time graph, if you don't have the positive and negative, it will just be like empty like this, because there is no velocity, because the velocity is 0. So if you want to draw it, you draw on this line, on this line. That's what it is, right? That's a body at rest. There'll be no acceleration, right? Because the person is not moving. It's just like you sitting on the bench, no motion. Do you have acceleration? No. So there's no acceleration graph. Good. Now, if this person is moving now, like this second case, draw this time graph, this time graph for the moving, for the body moving. So I've made a mistake. For the body moving with uniform velocity. So now we're talking about the body have uniform velocity. Now let me use another color so it's in the sheet. Uniform velocity now. Now if the body is moving with uniform velocity per se, right? Okay. Now what will be the displacement? So you have to, okay, if you look at the displacement, we said displacement. So this plane to a second. So you have positive, negative. This uniform velocity means that the acceleration is the distance displacement is changing constantly. So it means that it's a straight line in the middle. So we have something like this. We have this, right? Then now, what will happen to the to the velocity time graph? So we have this. The velocity time graph might have velocity. This positive, negative. I'll let you know just what this is uniform now. Uniform velocity in the velocity time graph. The acceleration time graph or displacement time graph have this. Then our acceleration now. This acceleration. This positive, this negative. What do we have? We're going to just have a zero because a uniform velocity means, as I said, when the inverse is uniform, we have what? Zero acceleration. So we'll just have the graph like this, right? So you're going to have this system like, okay, this is constant. So even the same thing for this distant time graph, we just have this. If you have to distant time graph, we'll just have this. A straight line. Speed time graph, if you want to draw the speed without a negative side, you just have this. And the same thing for acceleration, so you have that. So this is how the graphs look like if you're doing to work with uniform velocity. So you see that this might represent uniform velocity. This might very uniform velocity. So this one is the velocity time graph. But this one is in displacement time graph or distance time graph. But you look at this one, this uniform or constant displacement, this is zero velocity. So you see how it looks like. So you see that because my uniform velocity, the acceleration is zero. So that's how you get it. Now let's look at one problem that's always common amongst us. Like we always used to throw stones upward, right? We used to throw stones upward. So let's look at a situation whereby stones have been thrown upward, like you throw a stone upward. So what would be the velocity? Okay, let's look at a situation where a stone is thrown upward, right? You throw a stone upward, like okay, this is you, this is you, like this, and then you have a stone in your hand, and then you throw the stone upward like that, and the stone goes up, reaches your hand, and it comes back to your hand like that. You catch it. So now they actually draw the graph of the situation. So what are you going to do? So the first thing, as you're throwing the stone, there's a velocity going up. It reaches this height, and then it starts coming back. There's a height that it comes back. So how does the velocity grow? How the distance time graph? So when a ball is thrown upward, for example. So if you look, for example, the displacement time graph, so you have, I said we have to draw both negative and direction and positive direction. So for displacement. So in doing this, you have to first decide which side is positive and first negative. So if it's something is going up, let me say it's positive, and when it's coming down, it's negative. So you have to choose the two sides. When you're doing problems like this, you have to choose minus negative and minus positive, right? And so on. So when the bus is going up, what happens? It's positive. So you have something like from your hand. So you're starting from a zero displacement now. It goes up, it's positive, it goes up like this, and then it start coming down, right? It goes up and start coming down. So you have something like that. So you have this one like the maximum displacement. It start coming down. Start coming, yes, it start coming down. So so that's what you have start coming down like that. So now another thing that we're going to look at is now what now be the velocity time graph. So we look at the velocity time graph. If you're looking at the velocity time, so we start looking at the velocity. The velocity starts at the particular value. As you're throwing up, it starts at the particular value. And now my up is positive. So when you start at a particular value, so the velocity was increasing because the velocity is going up at this point at the maximum height here. Maximum height. The velocity is zero. The velocity is zero because the height there is constant. Means that it's a constant displacement at that point, and there's a momentary rest at that point. So the height is the same. So it's a momentary rest. So there's a time that this stone stays here for some time, short time before it starts dropping. So at that moment is zero. So the velocity is moving from a particular value, which you started throwing it with, and then it's moving down to zero velocity. You move down to zero velocity, and then when you reach this point now, when it reaches here, because from here the velocity is decreasing to where? Zero. It reaches here. Then after it reaches here, it starts going to the negative side. This is the negative side. It starts increasing back So instead of starting now, yeah, so it start going now back. You start, this is u, it will be negative u. You start increasing back until you come to this back center of value that you have in your hand, and negative u. So that's how the velocity time graph now looks like, because it's decelerating. Now, if you want to look at the velocity, the acceleration time graph, if you look at this acceleration time, so you said this man here is what? From your graph, when you say something is this gradient here will be uniform. The gradient will be what? Uniform. So in the positive side, this is the positive side, the gradient will be like this. In the negative side, the gradient will be like that. Because it will say it's constant. A uniform velocity is a constant acceleration. Right? It is constant. The acceleration is constant, like that. Right? Yes. So that's how it look like. So now if you want to do the distance, displacement time graph, also the distance, if you want to do distance and time without the negative side, would you have something like this? Then this one, you're going to just have, in this case, you're not going to have this one, we'll just have something like this. The speed time graph, you're going to have something like that. And the acceleration, you're just going to have the same thing like this and this. So that's the same thing that you do to for a body moving upward, right? So that's how you try to interpret. But now, in most of the cases, this one at times in your GCE, they will really give something like in the lower levels too complicated, like this, or something that's more complicated. But they can give you a system, for example, like they can give something like a ball was moving, a graph like this, a velocity time graph. A ball was moving this velocity, and this is time, or like this, and then came back to rest. So the ball was moving with a constant like this. You have a zero, this was 2 meters, and then it comes back to rest. They'll ask you now, they give you time, this is 10, this is 5, this is 2, like that. They'll ask you to describe the motion. This is A, this is B, this is C, this is D. Describe this motion. How do you describe this motion? Is that from 0 to B, from A to B, what is the motion? This velocity time graph, you have to know this shape. What the shape looks like? It's moving, it's constant, it's uniform acceleration. You should know the shapes of the graph. When it's like this, means that this one is like this. So in this part, you have to look at this graph that is like this. This part, you have to look at the graph that is like this. This part, you are looking at the graph that is like this. That's how you look at it. So that three, this 1, 2, 3 have been joined. All of this have been joined to this. So you have to take note. So you have AB equals to uniform acceleration, and so you have AB equals uniform acceleration, and then B, sorry, this C, sorry, C and T. So BC now be what? Constant what? Constant velocity. So that's how you interpret the graph. And then CD will give you what? Will be what? Uniform deceleration. So you have described the graphs. AB is uniform acceleration from this graph. BC is constant velocity. Great. CT is what? Uniform deceleration. And they can give the same thing for displacement. They can still give a graph like this. I give a graph like this, and this displacement against time. Now describe this motion. This is A, this is B, and this is C. So you have to understand, if AB is like that, it means that it's constant distance, right? So AB now in this case will be constant distance, or this constant displacement, depending which one they are talking about. And BC will be equal to what? Uniform will be uniform velocity in the negative direction, right? So the velocity is uniform, but it's moving in a negative sense. So that's what you talk about. But the acceleration in this case now will be what? Constant. Sigma is velocity. So you also know how to differentiate between the graphs. A velocity time graph, please, the gradient is acceleration. The area under the graph is distance. For a displacement time graph, the acceleration, the speed, the gradient is velocity, right? Acceleration time graph, the displacement, the area under the graph is velocity, and we don't have a physical significance of the gradient. So that's what you need to understand. I need to know to differentiate the graphs differently. And if they say, okay, this man is constant velocity, what do you mean in respect to acceleration? If they say this man is constant displacement, what do you mean with respect to velocity? Because you move from displacement to velocity and from velocity to acceleration. That's how you move. If I say my displacement is constant, means my velocity is zero. If I say my displacement is increasing constantly, means that I have a uniform velocity, and then from uniform velocity I'm going to have what, a zero acceleration. So you need to understand the different graphs in that direction. Now, and another thing they always say is that, yes,